Okay, so today we're going to be talking about Unit 4.6, the fundamental theorem of algebra. Okay, so I really want you guys to think about what does the FTA, the fundamental theorem of algebra, imply? How might this theorem be useful to us? So think about what we've been doing in class. What have we been solving for? So we've been solving for roots, for zeros, for our solutions, right? We're solving for x. So the fundamental theorem of algebra helps us solve for x. We know how many x's we need to find. How might this theorem help us solve? Kind of just answered that, right? We know how many roots that we are looking for, and if we know how many roots we're looking for, then we know when we are finished, basically. We know if we have multiplicities, we know if we are going to have imaginary numbers by looking at how many real answers we get. All of this can be utilized when we have the fundamental theorem of algebra. Okay, so for the first example, I think we actually did this in class. So we have x to the third plus 5x squared plus 2x minus 8. So I start by finding all possible roots. I look at my leading coefficient and I look at my constant. So all possible roots means for 1 it's going to be plus or minus 1. For 8 it's plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And remember, we do the constant over the coefficient. So my constant numbers, all of my constant factors, divided by all of my factors of my coefficient. And for this, since my coefficient, the lead coefficient was just 1, that means that when I divide each of these numbers by 1, I get those numbers. It's going to be the same list. So my possible roots are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So next I'm going to just take these and solve for a root, to see which one of these would be a root of my polynomial. So I'm going to start with positive 1, and my polynomial is x to the third, so it's going to be 1, 5x squared, so I'm going to have a 5, 2x, so I'll have a 2, and then minus 8, so negative 8. So then I bring down the 1, I multiply, put my answer here, and then I add, and I get 6. So again, multiplying, I get 6, and add, I get 8. Multiply again is 8, add, I get 0. So I can tell that this is definitely a root. 1 is a root because my remainder was 0. So using that, I've factored out the 1. So the binomial for 1 is x minus 1. And then here is my leftover quadratic. It's going to be an x squared plus 6x plus 8. And then there are a couple different ways I can solve this. I can use the quadratic formula, or I can simply factor it. If it can be factored, it's perfectly fine to just go ahead and factor it into two binomials, but you will need to know how to do the quadratic formula, because sometimes we might have imaginary numbers, and it's easier for us to use the quadratic formula to find our roots. So the two numbers that multiply to give me 8 and add to give me 6 are going to be 2 and 4. So all three of my roots, I've got x minus 1, x plus 4, x plus 2. So the actual roots then are going to be negative 4, and negative 2. To find the roots from the binomials, we simply take the binomials and set them each equal to 0. So this would just be plus 1, that's how I get the 1. X plus 4 equals 0. I'd minus the 4, that's how I get negative 4. And then same thing for x plus 2. Minus 2, I get x is equal to negative 2. Okay, so that's how I end up with my actual roots. And I know from the fundamental theorem of algebra that I should have 3 roots because my degree is 3. And here I have 1, 2, 3, so I am done. Okay, for the next one, now I have x to the 4th power. So I'm going to do the same thing I did before. Started out the same way. I'm looking for all possible roots. So my factors of my lead coefficient are just plus or minus 1. And my factors of my constant are also plus or minus 1. Meaning that when I put my constant over my lead coefficient, I am going to end up with simply plus or minus 1. So I'm going to try positive 1. So here I've got 1, negative 2, 2, negative 2, 1. Go ahead and do your synthetic division. So multiplying, and then adding, and then multiplying again, and then I add, multiply again, and add, and then finally finish out that multiplication. Okay, so I get the remainder of 0, so yes, this is a root. So I am going to have my root, my x minus 1, and the quotient that I had was x to the third minus 2x, or I'm sorry, 1x squared, or x squared, plus x minus 1. And I get this from what I had left over. So this was originally an x to the 4th power. It was 1x to the 4th power. That's where I got this 1 from. Okay, so when I have my quotient, I'm taking x to the 4th power, I'm dividing it by x minus 1. So x to the 4th power divided by x minus 1 is going to give me x to the 3rd. So that's how I get x to the 3rd here. Minus 1x squared plus 1x minus 1. So that's where this quotient came from. And so now I am ready to simplify it. So in class we were having a little bit of trouble with this because we were using the synthetic division to test if -1 was going to be a factor, and it turned out it wasn't a factor. So what we are going to do now then is using factoring by grouping. So I'm going to take x to the 3rd minus x squared plus x minus 1. And all I'm going to do is I'm going to group the first two terms together. I'm going to change my color here. Okay, I group my first two terms together, and I group my second two terms together, and then I factor out the greatest common factor. So this is factoring by grouping. We did it a while back, so hopefully we remember how to do this. So I'm bringing down my x minus 1. And then here, when I factor out a GCF, the GCF of x to the 3rd minus x squared is x squared. That's what I can factor out of both of those. And then in parentheses, I end up with x minus 1. Okay, and then for the second one, there is nothing I can factor out of these two. The only thing I could really factor out would be a 1. And I still have x minus 1. Okay, and then from there, continuing to bring down my x minus 1 here, I am going to pull out the x minus 1. Since both of these terms have an x minus 1, I can factor out the x minus 1. So that's going to be another one of my factors. And then the second factor is going to be what's left over after I factor out x minus 1. So think of it just like covering up the x minus 1s. I factored out the x minus 1. What do I have left over? I have an x squared right here plus 1. Okay, and then finally, I need to take the x squared plus 1 and I need to factor that. Remember, fundamental theorem of algebra says that I should have 4 roots. I have x to the 4th power, so there should be 4 roots. Here I've got 1, 2, and then the other 2 are going to be here. I just need to figure out what they are. So we can actually figure out what they are by using the quadratic formula. So let's go ahead and go to another page. Okay, and I just copied this down straight from the last page. I'm taking this, plugging it into the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And if I'm using x squared plus 1, remember the a term, your a that you're plugging in, comes from what's in front of the x squared. So right now, the x squared doesn't have a number in front of it, meaning that it's just a 1. So my a is equal to 1. Your b term is usually what is in front of the x. Now, I don't have a number in front of x, right, because I don't have an x. If you don't have an x at all, the b is just 0. And then the c term, c is whatever your constant is, so in this case it's just a 1. So this one shouldn't really be that bad. So it's going to be the opposite of 0 plus or minus the square root of 0 squared minus 4 times 1 times 1 all over 2 times 1. And that's just plugging in a, b, and c, plugging this into my formula. So negative 0 is just 0. And when I take 0 and I add or subtract it to anything, it doesn't really do anything to my number, so I'm not really going to write the 0. You can write the 0 if you want to, but you don't have to. It's not necessary when we simplify. So this is plus or minus the square root of 0 minus 4 over 2. So continuing to simplify, that's plus or minus the square root of negative 4 over 2. Okay, and then to get rid of the negative, we take an I out. So this is plus or minus I square root of 2 over 2. Or sorry, square root of 4 over 2. And the square root of 4 is equal to 2. Okay, and then finally the 2's end up canceling. So we get plus or minus I. And there are our other two roots. So two of our roots were 1 and 1, right? Our two binomials are x minus 1 and x minus 1. And when we solve, we get 1. You know, let's write this in another color. Okay, our roots then, the actual roots are 1, 1, and plus or minus I. And these two roots come from the two binomials that we factored out. The other two roots, the positive I and the negative I, come from what we just solved for using the quadratic formula. And now that I have four roots, 1, 2, 3, and 4, because this is both positive I and a negative I. Now that I have a total of 4 roots, I know that I am done, because the fundamental theorem of algebra says that I should have 4 roots, because my polynomial had a degree of 4. And that's it. So I want you guys to go ahead and try this problem. And just a little hint, remember that when we have synthetic division, when we use synthetic division, we need to make sure that we account for every single degree. So if I'm starting with x to the 4th, I don't have an x to the 3rd power. That means that when I go ahead and set up my division, and I'm going to use the method that we saw in class today, the box. When I set up my division, I will have a 1 for the x to the 4th. That'll go here. I don't have an x to the 3rd power, but I still need a placeholder for x to the 3rd. If you don't have an x to the 3rd, that means we just use a 0. Okay, and then x squared has 15 in front of it, so this will be 15, and then negative 16. Okay, so you're going to go ahead and try your different roots. So remember, we're using the lead coefficient, we're using the constant. You need to find all possible roots first. After you find all the possible roots, then you're going to go ahead and use this setup, plugging in your root here. Okay, so I want you guys to try this instead of the other problem that I had you guys trying in class. We're going to try this one instead and come in tomorrow, see what we find.